This question was actually in your notes. So this one's not on that handout I just gave you, but it is in your homework. Okay, so it's on Math Excel. So maybe it makes sense to talk about this one. It wants us to find x that is going to force lines L and M to be parallel. Okay, something to think about is if they're asking you a question of what does x have to be for these lines to be parallel, you can actually approach the question with the assumption that L and M are parallel, and then go off of that. Okay, well, if they were parallel, what relationship would exist? And then solve it that way, and it'll end up giving you the same result. Okay, so if L and M were parallel, what are some relationships about some angles that we were looking at up here? What I'm going to do is I'm going to look at a transversal. Let's call this transversal S, and let's call that one T. Which one of those transversals creates most of, if not all of, the angles that we have information about, Connor? T. Okay? That's probably the most informative transversal. Okay? It's not necessarily going to be every time that you answer that you never have to deal with T. You never have to deal with S, but T is going to be the one here that I think is probably most beneficial to us. Okay? And if you don't know the answer to that, which one is going to be the most beneficial, redraw a picture with one of them, and then redraw the picture with the other one, and see which one kind of lends itself to helping you solve the problem. Now, when I erase that transversal S, 5x was only representing like that size of an angle. Does that make sense? So really, when I erase the transversal S, I'm really erasing that angle as well. Okay? So now I look at that. Is that a little bit easier to recognize some relationships? Okay, so you're saying that this angle here and that angle there are vertical. So you're going to transfer 5x plus 40 to right here. And then that would be same side interior with 2x, right? So you can say that 2x plus 5x plus 40 is equal to 180. Okay? Now, that's not the only relationship you could have made. Would you guys agree that that angle there and that one there are corresponding? So could I move 5x plus 40 there? And then what would you tell me about 2x and 5x plus 40 there? They're supplementary because they form a straight line. They're a linear pair, right? So linear pairs are supplementary. So that's an approach you could use. You could have moved, you could move 2x there. You could have moved, 5x plus 40 up there. Okay. But once you solve this, you get what? 7x equals 140. X is going to be 20. Okay. Now, if I go back to the original picture, what did I have to do with that 5x to get x? What did we do with it? Nothing. Okay. It's just a distractor. Okay. It's just there to create an intended confusion. Is that cool? All right, let's go to that handout I gave you, and we'll jump. Well, I'm not going to do every one of those with you, but we'll jump around a little bit. All right, so we'll start with question number 1 here. When looking at that, it says find the values of x and y. We've got we got multiple transversals here. If I look at that parallel line, which transversal do you guys want to look at first? You want to look at the kind of horizontal one, or you want to look at this slanted one? Okay, so you want to look at that one. So So in that situation, then you're going to find out that, if you cover this one up, you get y and 61. You said y was 61, right? What kind of angles are they? Corresponding. Okay, you got the right relationship. Make sure you got the right name with them. So those are corresponding. Okay, so then that's good. Now, in order to find out what x is, then there's a couple different approaches I think you could probably use here to find x. Okay, one of them, I think, probably the most obvious one is to look at that transversal there. What is that angle there in comparison to that angle there? Alternate interior. So the alternate interior angles are what to one another? Congruent. Could we have done this? And this is what I was talking about a little bit yesterday in regards to that there's usually multiple approaches to every problem. If I look at that, can I say that that angle there and this angle here are same side interior? Okay. If they're same side interior, they should add up to what? 180. Okay. Now, I'm gonna give you a fact here that we haven't talked about in this class yet. So you should be able to solve this without this fact, but I think you guys probably know how many degrees there are in a triangle, don't you? 180. So that makes this one here 59. Could I say 61 plus 59 plus x? So 59 plus x would be that angle there, right? Can I say that those equal to 180? So that would be 120, right? If I subtract 120 from both sides, do I still get x to be 60? Okay, so there's multiple ways of doing problems. Now, like I said, I introduced there the idea of 180 degrees in a triangle. If we haven't talked about that fact yet in the course, then there should be at least one way of doing it without that fact. Does that make sense? Okay. Does anybody know what type of shape we have here in number 2? That is a trapezoid. Okay. And it's called a right trapezoid because it's got a right angle in it. If I highlight my parallel lines, which transversal you want to look at? You want to look at the blue one or you want to look at this yellow one? If I look at that yellow transversal, okay, what are you going to tell me then about the relationships there? Okay, why? Okay, so you said 2y is congruent to 90 degrees. I do not disagree. I mean, maybe the word, we should say 2y is equal to 90 degrees, but I think you're telling me that this angle here and that angle there are congruent. Why? Okay. Okay. So what is the feature between these two angles then? Same side interior, and if they're same side interior and they are, what's the feature between same side interior from the theorem that we talked about the other day? Supplementary. Okay, so we got these two angles should be supplementary, right? And if they're supplementary, you have the equation 2y plus 90 equals 180, but you did the subtraction right away and got 2y to be 90 right away, right? Okay, or 2y equals 90. So then y does end up being 45, okay? But the reason, and now here's a situation that these are actually two angles that are same side interior, but they are indeed congruent. Does that make sense? Are same side interior angles always congruent? No. There is one and only one time that same side interior angles are congruent, and that's when we have one of them being 90 degrees. Okay? And what we find out then is if that's, so this line here, and this will be a theorem in actually the next section that we go over. If this transversal, I'll call this T, if this transversal is parallel to line L, let me rephrase that. If this transversal is perpendicular to line L, and line L and M are parallel, then it follows automatically that T is going to be perpendicular to M as well. It's going to be perpendicular to both. And it's because of what we just talked about. If they're supplementary and one's 90, the other one's got to be 90. Okay, if that one's 90, then these lines got to be perpendicular. What's the relationship between these two angles? Yep, they're same side interior angles again, so they should be, yep, add up to 180. So X will be 10. Take a look at number 3 and do that one on your own, and we'll come back a couple minutes and discuss it. All right. So what did you guys do first? Why? So you're saying you took that X and you put it right there? Yeah. Why did you do that? Don't go off looks. You moved 120 where? Okay, so you moved 120 there, and then match that up with. Okay. So you moved X and you moved 120. Is that what you're saying? Okay, that's what. Delaney, you're going to say something. Did you? Okay, so if this is X, you can move X here because they're corresponding. Could I have moved 120 right there because it's corresponding? Okay, so at some juncture, you have to move one of these two, but you end up with the fact that they're going to be supplementary, so X ends up being 60, right? So if X is 60, how do you go about solving for Y then? The corresponding. Maddie? Yeah. Yep. Okay. So we got 3y plus 6 equals 60. And we get 3y equals 54. 18. You're right. 18. Sorry. What'd you do? Fabulous. That works. Okay. So this is 60. So this has got to be 120, right? Okay. So then that angle there and that angle there are same side interior. So we can say 3y plus 6 plus 120 equals 180. What if I would have done that? What if I would have, at the beginning, didn't solve for X first? But I recognize this relationship that X equals 3y plus 6. That doesn't let me solve for X or Y, right? Okay, numerically. Okay, this is, algebraically, we have X solved for, and it's kind of what we talked about in Algebra 1. But I don't know what X or Y is right now to where I can actually solve numerically for the other one. Should I just erase that and start over? Why not? Okay. So once I find x is 60, now I can just plug that in, and I've got then exactly what we needed to solve for y. So if you are writing the equation from, and this is all mathematics. If you take a fact and write an equation that exists from that fact, but you can't solve that equation, that doesn't make that equation useless to you. Okay? Don't erase it. Just go on and see, okay, can I write more facts? Can I come up with another equation that maybe is solvable? Okay? And if you can find then x or y, then you can substitute that back into the other equation that you've already developed. Okay? Sometimes you might need to create another equation that has x and y in it, and you can use a system. Okay? Using substitution or elimination. Let's go down to, give that one a shot. So we're trying to prove L parallel to M, or you can make the assumption that L is parallel to M, and then solve for x and y. So x minus y, so the x minus y is this little angle right there. Let me highlight it a little bit better. So that angle right there is x minus y, and this one here is 2x. What'd you guys do first? Or what's an option? Hannah? Okay, so okay, I'm going to let's just be careful, because I agree with, you said that angle right there of 30 and that angle right there should be corresponding angles, correct? Is that okay there? So x minus y is equal to 30, okay? And I'm good with that. Now, I thought I heard you say that you took 2x, that angle there, and x minus y, that angle there, and said they were supplementary, right? Now, just be careful with this, because if we highlight the segments or the lines that make those, it'd be that one there, and then this would be my transversal. So if I just look at those, let me erase the other objects here. So we get rid of that, and that's what we would have, right? When can I say that same side anterior angles are supplementary? It's when that line there and that line there are going to be parallel, right? Okay, it's the two lines that are being intersected are parallel. And do we know, based off the total picture, that they are not parallel? Okay, so we can't say that those are supplementary, but what else can we say? Also, you said 5y is vertical to, you're saying you put 5y there? Yes. Be careful. Okay, because vertical angles are created by when two lines intersect, right? So that line there and that line there. So this vertical angle here is actually going to be congruent to that yellow one. Does that make sense? 5y would actually be, so I'd have to extend that line right there, and it would be, so 5y would be there if I did that, if I used vertical angles there. Any other ideas on? Question 10. Did you get x to be 50 and y to be 20? All right, so we want L and M to be parallel, right? So focus on those. Okay. Now the one relationship that we see based on that transversal is what Hannah gave us. That's the one where basically that's the wrong color. Well, there we go. Good enough. But that's where we can see the 30 and the x minus y as being corresponding, right? Is everybody okay with that idea? Now, that's all we get from that transversal. So let's look at the other transversal, which would be this one. Then visually ignoring that one, that would get rid of x minus y. It'd also get rid of the 30 degrees. So now we're looking at those things that are left over. What are you going to tell me about 5y and 2x? Alternate interior, so what's the relationship between them? They're congruent. So I say 5y is equal to 2x. Now, did either of those equations by themselves allow me to solve for x or y? No. So, you got some options here. Okay, I'm going to run through all the different ways we could do this. If I have x minus y equals 30 and 5y equals 2x, can I take this top one and say that is actually x equals 30 plus y? Is that fair? Yeah. Take the y right here and add it to both sides, and it isolates x. Now that I have that, can I substitute that down here for that x? So you'd be left with 5y equals 2. Now, x is being substituted with a quantity, so I put it in parentheses. And we subtract 2y. Is that okay? So then if y is 20, we come back up here, plug y back into, you can plug it back into any one of these that you want. If y is 20, then x is going to be left to be 50, right? Okay. Now, is that the only way that we can do that? What if we said, so I got x minus y equals 30, and I got 5y equals 2x. You know, could it have been as easy to have solved for y in this top equation and done the same kind of process? I could have let this one be, it would be x minus 30 is equal to y, and then plug y into the left-hand side. So that's one option. I'm not going to go that route because it's really the same type of algebra that we did here. Can we do this? Can we say that this bottom equation, can I rewrite it as negative 2x plus 5y equals 0? So all I did is I put that 2x on that side, right? Okay. Now, what that's called standard form for an equation of two variables. Okay. The x minus y is already in standard form. You guys remember taking and adding those straight down? Now, if I add straight down, does anything eliminate? Anything cancel out? No. Okay. So I've got to try to figure out what variable do I want to cancel out. And then at this juncture, you've got choices. Do you want the x's to cancel out? Do you want the y's to cancel out? Say again. Multiply everything by 2. So that top one by 2, and that will turn into 60, right? Okay. So we could go that route. We could cancel the x's. And then somebody else could say, well, I'm going to cancel the y. So my hope is that you can see there's a lot of different ways that we could do a problem. Okay. Those cancel when I add straight down. This gives me 3y. This gives me 60. Does that still give me y to be 20 like it did using the other route? Okay? So here's my thought. There's at least, so 1, 2, 3, 4, 5, 6. I see algebraically, once I have the two equations, I see 6 ways of solving that equation once I have the two equations. Does that make sense? Okay. Now, this problem, there's only the one way of coming up with these two equations in this one problem. So overall, there's 6 different ways of doing this problem. If there were maybe 2 different ways to get that blue equation and that red equation from the picture, then that would mean, and there's 6 algebraic ways of solving it, that would mean there's 12 total ways of doing the problem. Okay? And you can start to see, okay, well, if that's the way that we're going to do this, that any one problem could have, anywhere from 5 to 50 different ways of doing it, depending on how you structure your algebra once you generate the equations. Okay? So if we're talking in class and something doesn't make sense because you didn't do it that route, okay, let me know. We can talk about it. We can see if your route works or not. Okay? Yes? And that's fine. So how did you... Okay, I see what you're saying. So you did, okay. So you took this one and let it be x equals 30 plus y, right? And this is I like this. I prefer this actually because this is substitution that not every algebra teacher is going to teach to you. But if this is 2x, if I can find what 2x is equal to, I can fully substitute 2x, right? So are you telling me that you took that x equals 30 plus y, you doubled that, and then doubled this? Say it again. Okay. So you kept y on. Oh, okay. So you put your 2 there, and 60 there. And then what'd you do? So you took this 2x. Oh, I see what you're saying. Okay. So I was doing the inverse substitution that you did. Okay. So he's saying so he doubled everything here and got 2x minus 2y equals 60. And they say, okay, well, 2x is the same thing as 5y. So you came up here and replaced that 2x with 5y. You got 5y minus 2y equals 60. Okay? What I was doing is, so you said x minus y equals 30. If I said x is equal to y plus 30, and then came down at 5y equals 2x, if I double that, now I'm going to substitute that. You substitute the 5y side, I substitute the 2x side. So you solve for y first. I would solve for eventually x first. I guess you solve for x first. I would solve for y first. Does that kind of make sense? So lots of different approaches. And my thought is just be cognizant of if you're working with a partner, working with a friend, somebody's trying to explain something to you, and it doesn't make sense. You don't see it their way. That doesn't mean that's the only way that they can do it. Does that make sense? Okay. And that there are so many problems throughout the rest of the course that are that way. What I want you guys to do, so we're going to stop there. By Monday, which is, I think, more time than what's necessary, and you've got 14 minutes here in class. What I want you to go through is the rest of those problems that we didn't do and solve them. Okay. And then you're going to get into Math Excel, and there's going to be an assignment. It's called 3.3 worksheet, and it's got boxes for you to type in your answers. Okay? Why? So you got some of those. We already did some of them. And then you can finish them. Yeah. So I think it's important I like Math Excel because it gives you the similar exercises, right? And that removes a little bit of that stress of being wrong the first time. But I do think that we should work or try to at some point mimic that situation that we have on tests where this is the one and only option or chance that I have.